All right, we're still thinking in terms, we're still doing a lot of one-point perspective here. I'd like to go back and cover a few basic things that might have been best if they preceded what I just showed, but I think nevertheless it's good to get all this stuff down. This one is one-point perspective, and it's called Draw Two One-Point Squares Based on a Given Square. So let's do that. Let's have a given square, meaning there is an already existing square, one-point square that already exists, and so based on that, we're going to find other one-point squares. So here is a horizon line, and then down here is a given square. So, I think what I'd like to do, let's pretend that we don't have the horizon yet. Let's make it even more difficult. Let's start with just a given square. Say you have this situation. You're going to do an illustration, and you need to do a set of squares. They have to be square, but you don't know where the horizon is. So let's say here's what you have. You have this given square here. So maybe you have a photograph or something like that, and what you're going to do is say you're going to do a display using a square motif, maybe some squares on the ground at different levels, maybe up in the air even. As long as these squares are parallel to the picture plane, we can use this same method to assure that each one of them is actually a square. And here's how we do this. And I'm going to count the steps. Step number one, I'm going to carry the left side back like this, and that's step number one. I'm putting an arrow on that step. Step number two, I'm drawing the right side back to a vanishing point. Now we know that by the way, all of these squares, let's assume that all of these squares are level. That means they're parallel to the ground plane. So what I've done here is I've located the vanishing point. And by so doing, I have also located the horizon line. One-point perspective, vanishing point, as you know, is also the center of vision. What I'm doing now is I'm drawing a diagonal across the square. Now, I've used 4 steps to do that. Let's draw. Now, these squares aren't the same size. The size may be different, but what I'm doing, I just wanted to be sure that each one of these is actually a square. That's the purpose here. So they're varying sizes of squares, but to guarantee that they're square, I can use that measuring point. So let's do this. Let's draw lines 5, 6, and 7. 6 and 7 are drawn back to the vanishing point. Now line 8, by drawing from this bottom right corner to the measuring point like this, where it crosses the left receding side, that will give me the depth of another square. That will be line 9. So the object of this particular exercise right here is to be able to draw 2 squares based on a given square. So you see, I can put all kinds of squares on the ground. They won't necessarily be the same size, but I can be assured that each one of these is actually a square. That is, they have 4 equal sides. So let's do this. Let's float one up in the air. Let's start one up here in the air above everything. And let's draw line 10. And then let's draw the 2 sides of that square back to the vanishing point. Step 11 and step 12. Step 12. And this gives us the 2 receding sides of the new airborne square here. Now let's start from this upper right corner and draw to the measuring point like this, line 13, and you see where line 13 touches the left receding side, here is line 14. Now I know in each one of these exercises I put the measuring point on the left. It doesn't have to be on the left, it's just that I must be kind of a pinko commie or something like that. I'm always drawing toward the left. So let's then do this next exercise, which is find the station point from a given square. Now, why would you want to do that? Well, there's a reason to do that. If you have a given square And in this scene, you want to draw a 2-point object in the same scene as a 1-point object. It is necessary, in order to do that, to have 2-point and 1-point in the same scene. It's necessary to find the station point. What I'm going to do here is the first half of that. Later on, as I get to the more of the 2-point perspective, I will then incorporate the second half. But for now, what we're going to do is just find the station point from a given square. So here we have a given square. Once again, we don't know anything except in this photograph we have a given square. We have two sides converging like this toward a vanishing point, I presume. And let's have the back of the square. Okay, that looks awfully deep. Let's make it a little less deep than that. It just looks almost too deep. I'm going to make it about this deep here. So I'm going to carry the two sides back to a vanishing point. Now I'm starting from a given square. This is line 1 and line 2. And this gives me the vanishing point, center of vision, which incidentally also gives me the level of the horizon. So those are lines 1, 2, and 3. Line 1, line 2, line 3. Line 4 will be a diagonal drawn across this to find the measuring point. And that will be line 4. All right? Line 5 then is a distance line drawn from the center of vision vanishing point straight down the page like this. And along this line, I'm in hopes of finding the fabulous station point. So one of the ways I can do that, oh, by the way, let's number this line. This was line 5, and it was drawn this way. Line 4 was drawn this way. I'm trying to put arrows on the lines that indicate which way they were drawn. Now, drawing from the measuring point, a 45-degree angle line will now give me the station point. From the measuring point, a 45-degree angle line like this. This then is line 6, and I need to indicate in here 45 degrees, and this gives me the station point. That shows me how far away I, as the viewer, need to be to get a square that deep. Now, this is just the first part of a later exercise, and which we will then locate a 2-point rectangle in the same image. But for now, let's just do the first half. A little bit later, when I get to it, we'll do the second part. Okay, so that was called, according to my notes here, that was called find the station point from a given square. This next thing is called divide a line into 5 even spaces. Divide a line into 5 even spaces. Now, in order for this to happen, the line needs to be parallel to the picture plane. It can't be drawn at an angle that goes back away from the picture plane. It could be a vertical line, or it could be a line at an angle, as long as the angle is parallel to the picture plane. But it can't be something receding back in space. It has to be parallel to the picture plane. So I'm arbitrarily choosing a vertical line like this. And I'm going to call this line AB. And I'm going to divide it into 5 equal units. Now, I know what you're thinking. You're thinking, why not just measure that line and divide it into 5 equal units? Well, 1, 2, 3, 4, 5. Funny, I just happened to make a 5-inch line. Let's make it so it's hard to do. But let's say this. Let's say I measured a line here. Let's say I measured a line and it came out to be 8 13/16 inches. Well, how am I going to do that? Divide 5 into 8 13/16. So 5 into 8 goes 1 time. That leaves 3 13/16. Divide 5 into... That's too hard. So here's what I want to do. There's a geometric way I can do this. It's very easy. And it's involved in 4 steps. Step 1, draw a line tangent to line AB. Tangent at any angle, by the way, any angle you want. So I'm picking an arbitrary angle, and tangent means touching at one end. So I've got a line that's touching at one end here. So now on that line, I'm going to measure 5 equal units. 1, 2, 3, 4, 5. All right, I've measured 1, 2, 3, 4, 5. So step 1 was to draw a line at an arbitrary angle and a tangent touching at one end of the line. Step 2 was to measure 5 equal spaces on that line. Step 3, draw a line from 5 to A, like this. Now, using a see-through ruler like this, I can draw lines parallel to 5A from 4, 3, 2, and 1. And this will divide that line into 5 equal units. So, from 4, 3, 2, coming down here to 2, and 1, this will divide this line into 5 equal units. So you see I have 1, 2, 3, 4, 5 units. Now I know what you're thinking, well, that may not work other ways. Let's prove it. Let's prove it out. What if I took a tangent line at this angle right here? Let's do a tangent line at this angle. I take any angle that I want, and I can measure it in any scale that I want. So I'm going to measure this way now. 1, 2, 3, 4, and 5. All right, 1, 2, 3, 4, and 5. And I'm going to draw a line from 5 to A. Now I'm going to parallel that line from 4. Line up with 4 here. 4. Now from 3, paralleling line 5A. From 3. Then from 2, paralleling the lines above. Whoa. Well, it'd be nice if it worked out. That one's missing a little bit. Let's find out why. I think my initial, I think I know what's wrong here. Let's figure it out. What I did here is I didn't draw from the exact point here, and I need to be absolutely parallel to the other lines from about right here. It's closer, pretty close. Anyway, you could see that you get the same, no matter what angle you pick and no matter what dimension you pick. You can divide that line into 5 equal units. So we've just divided a line into 5 equal units. I wonder if I have room down here. I think I can draw in here the next process, which is divide a wall into 5 equal vertical spaces. So let's do that. Let's draw a horizon line and draw a wall. I think I can get this in just fine here. A wall going off to a vanishing point like this. So, here is a wall. I have to make it a specific length, though. It can't just go off forever. So let's make it this long. And what I want to do is find 5 vertical spaces properly foreshortened on that line, or on that wall, excuse me. This is line A, B, just like we did before. So this whole thing up here is step 1, doing this whole thing with line A, B here. So what I'll do is draw from B a tangent line at an arbitrary angle. Let's see, 1, 2, 3, 4. And I'm going to measure 5 equal units on that line. 1, 2, 3, 4, 5. And I'm going to draw a line from 5 to A, like this. And then I'm drawing lines from 4, 3, 2, and 1 that are parallel to 5A. So I have to be real careful so I don't have a screw up like I did last time there. Okay, about right here. And then from this one, okay, then from here, again, I'm paralleling 5A with each one of these, supposedly. Then one more. All right, So now that was step one, dividing AB into 5 equal units. That whole process we did up here was the first step for this. Now the next step for this is from each one of those spaces, draw lines toward the vanishing point like this. And you could stop at the back wall. You don't need to draw all the way to the vanishing point. So I'm drawing toward the vanishing point, stopping at the back wall. I'm using a thicker pencil than I normally do because I think it'll probably photograph better. So I may be getting a little bit cruder drawing than I'm used to. But okay, so what I've done now is the first two steps. Step one, divide line AB into 5 units. Step two, draw lines from each one of those units to the vanishing point. Step three, draw a line from corner to corner on the wall in either direction. I've decided to go from B to its opposite corner up there. Now, here's the deal. That was, by the way, step three. Step four is where B crosses each one of these lines, we make a vertical. So lining up with each one of those points, make vertical lines here. So you see what it does, it divides that into 5 foreshortened vertical spaces.